Alright, chapter 5.1 covers three or four operations. Of course, the fourth operation, if you don't know, is the least favorite operation, which is division. But it is a big section of material. I would rather give you information today so that tomorrow you can actually get the full day of practice. The rules today that you encounter should be review, but again, the application is a little bit more grown, more mature than that of what you saw in Algebra 1. First thing you should see that you already kind of recognize is adding and subtracting polynomials. It is the easiest portion of the chapter, but typically what happens is because it's mixed in with a whole bunch of things that are difficult, that people overthink it when they see it. Just make sure you understand the difference between the two things. When you see the plus sign in between parentheses, it is weak. It does not require extra work. Just go ahead and combine your like terms. But what most people do wrong whenever they deal with this stuff is they bump into the minus sign and they don't see it as being dangerous, and they just kind of take a shortcut or some sort of other way, and it ends up not working to their advantage because that minus sign causes them problems. So if you see a problem, again, the first thing you've got to start doing is make sure you train your brain to recognize when to do the distributive property, when to do the other things. In this case, this plus sign in between means you're adding these things, and so what you want to do is just simply combine like terms. Because the plus sign is weak and doesn't do anything, I can go ahead and just add the way it is. 5 minus 7 is negative 2x to the third. You also have a plus 2x squared. You have a 9x, and you have 15 and negative 21, which is negative 6. So again, negative 2x to the third, excuse me, plus 2x squared minus 9x minus 6. And so with all that, that's all it is. This is what you call standard form. Whenever you go from the highest power to the lowest, typically you want to put your answers in standard form because that's usually how your answers are going to be lined up whenever you work them out later on multiple choice things. On the next question, this is the one that you want to be careful on, because if you don't, you're going to mess up and do something really small and silly. On this question, it is smart if you rewrite it. So if I were you, whenever I see a minus in between, again, that's a dangerous sign. One of two ways to do it is to rewrite it, which is the best, safest way to do it, although not the fastest. Bring down your 13, bring down your negative 7, bring down your negative 8. Those stay the same, but this means switch those two things. So a negative 5x squared comes out and a positive 10xy comes out. And from there you put it in your best form. In this case, you've got 13 minus 18, which is negative 5, and negative 5 and another negative 5 make negative 10x squared, negative 7xy, and positive 10xy makes a positive 3xy. I believe that's all that can go together. The other way you can do this whenever you have it in this form is to simply switch this and carefully make sure you switch those two things. I usually do it that way, but again, until you kind of get used to it or practice that skill, you want to make sure you do it in a way that works best for you. Multiplying polynomials, this section has plenty of material. Really, it's everything that causes all the issues when you had it in Algebra 1. The majority of your studying should be here. It has a good amount of information that you've seen, but this material requires fluency and good instincts. What I mean by that is, when you learn this, or you did learn this last year in chapter 7, and when you learned it, you had all the rules, you had all the things you were supposed to do, and just by my experience of teaching, most students learn the rules, they read the rules, they study the rules, and then they always have to go back to notes to see how the rules work. But you want to kind of make sense of them, and that's what I'm going to try to do, and I explain them here today. Monomial, first off, is just some key vocabulary here. Monomial, I don't know if you know anything about headphones, but a mono signal means it's just one signal, whereas stereo has a left and right signal, but mono is usually for one, so it's a polynomial of one term. That would be something like 3x squared or 4xyz. That would be one term, that would be one term. Each of those would be monomials. The degree of a monomial is found by looking at the number of variables attached to the coefficient. If you remember, the coefficient is the number in front of the term. So if you want to know what the degree of 6x to the fifth y squared is, you got 5x's, 2 y's. This would be 7. Notice we don't even pay attention to the number in front because that has nothing to do with the degree. On this one, be careful, because you've got to remember that m means that there's one m and four n's. That would have a degree of 5. Again, we don't care about the negative or the 9. And then on C, it has nothing at all attached. That would be a degree of 0. When we were talking about standard form earlier, standard form usually goes from the highest degree to the lowest degree. So if you were putting these down, you'd put that first, this second, and that third, if that was the case. Polynomial is pretty much most of the stuff you've seen where it's got more than one term. Everything is a polynomial, but it's just whether or not it's a monomial, which is 1, binomial, which is 2, trinomial, which is 3. But if you want the degree of anything that is more than 1, find the highest degree, and that represents your overall degree for that problem. So with what you're looking at, if you wanted the degree of this polynomial, again, I'm just going to give you 1. This is a 1. This is 1 and 2, which makes 3. This is y to the third, which is 3. This is 2. You don't add them. You don't do anything spectacular. You pick the highest number. It doesn't matter if there's a tie. The degree of this is 3. And that's all you have to do. So if you want to know what the degree of a polynomial is, look at the highest power. That would represent, or the highest number of exponents or variables attached, and that would be your degree. There are 7 power rules, again, that must be applied as needed. You've seen them before, but again, it's important that you actually understand them instinctually. That means when you see them, you must be able to understand why what happens is going to happen. So write these down so you can get what you need. X to the third is x times x times x. That's how it expands. X to the second is xx. I'm going to go down here. That would be 5 x's put into a group, which ends up being x to the 5th. The key thing you want to know here is you've got to visualize it as this is 3 x's and 2 x's, which makes 5 x's. Your key here is to add powers. Again, 3 x's here, 2 x's there, make 5 x's all together, so you end up adding them. But visually, this is what happens. You don't want to do all that. You just want to be able to look, say 3 x's and 2 x's make 5 x's, and again, instinctually, you need to be able to see that the answer is x to the 5th. The quotient of powers, again, if you don't remember, this would be 6 x's up top, 4, 5, 6. 2 x's on the bottom. If you remember, anytime you have something on top and bottom, they cancel, leaving me with 4 x's or x to the 4th. Keyword here is always subtract. Whenever you're doing, sorry, that should be quotation marks. Whenever you're doing a fraction. Now the key thing here is that you subtract top minus bottom, because if you don't, you're going to get caught up and you're going to make a mistake on the sign. But you want to do 6 minus 2, which is 4. If that was 2 on top, 6 on the bottom, you notice that there would be 4 x's on the bottom, which is going to lead us to something else, and 2 minus 6 is negative 4, which is what you would have. Now the negative exponents, again, you should have seen. I think we talked about this in one of your bell ringers. What happens with a negative exponent is that this exponent, or this variable, does not want to be where it is, so it simply moves. This represents a top value x because it would be x to the negative 4th over 1. So this is a top number, and it simply moves to the bottom where it's happy. This one here, 1 over x to the negative 3rd, is a bottom x. It wants to be moved to the top where it's happy. So again, if you have a negative exponent, it's kind of like saying that that exponent is, or that variable is not happy in that neighborhood. It wants to move to the other neighborhood. So this x lives on the bottom neighborhood. It would be happy on the top. This x lives on the top neighborhood. It would be happier on the bottom. But again, you've got to make sure you understand how negative exponents affect it. They do not affect the sign of the answer. They simply affect the location of that piece. This one here would turn to 4 x to the thirds. 1, 2, 3, 4. And I'm not going to break it all the way down, but we know that represents 3 x's, and 3 more x's, and 3 more x's, and 3 more x's, which ends up being x to the 12th. Here the word is multiply. And the easiest way that I remember that is what happens whenever you have a 3 parentheses 4. In math, whenever I see 3 parentheses 4, I'm going to multiply those two things. Now taking that back to your first one, those were not separated by parentheses. It was something like x to the 3rd times x to the fourth, and so there are 3x's and 4x's. But whenever there's a floating power, pretty much you just multiply by that power. That then expands onto the power of a product, where your keyword here is to distribute. This ends up being x to the 4 times 3, and then y to the 2 times 3, which is equal to x to the 12th, and y to the 6th. Again, the keyword here, anytime you have a floating power, is that you distribute that power to everything on the inside. And again, it's common sense things, but you just have to kind of translate them over to what we're doing with this stuff right now. Again, with this problem, same thing. Even though it says power of a quotient, it's the same rule. You simply distribute x to the 15th over y to the 20th. Y to the 20th is happy where it's at. X to the 15th is happy where it's at. That's as far as you can go. Again, the keyword here is to distribute. Anytime there's a floating variable or floating exponent on the outside with everything on the inside, you simply distribute it to everything in that problem. And the last thing is the zero power, or x to the 0. And just to prove this to you, I want to show you what 15 to the 0 is. I want to show you what 26 to the 0 is. I want to show you what negative 4, actually parentheses negative 4 to the 0 is, what 1.2345678 to the 0 is, and what that means to you is that anything to the 0 power is 1. And that's important because it actually works like that whenever things cancel out. The examples I have aren't exactly like the problems that I gave you, but again, the only way you're going to learn this is by kind of experiencing what's going on. The key thing to remember, especially whenever you have a problem like this, is that you want to make sure you do numbers first, then variables second, and do them individually. So if I were you, I would look at 2/5 times 4 times negative 10. Again, looking at the signs, there's only one negative. That means my answer is going to be negative. And again, off to the side, I would do 2/5 times 4 times negative 10. Well, here's the thing. Because it's all being multiplied, I can do it in any order I want. 4 times 10 is negative 40. If you remember, the number multiplies to the top. I think we talked about that, or if we didn't, we should have. But the number multiplies to the top, but it also cancels with the bottom because it's the same thing as 2/5 times 40 over 1. And so these numbers will get pushed together. So what ends up happening is 5 goes away, turn this into a negative 8, making the answer negative 16. On your calculator, you could simply put 2/5. Actually, I'll do it on the other one, just to show you that it doesn't matter as long as you type it in the right way. So 2/5 in parentheses, like we learned, times 4 times negative 10 gives me a negative 16. So the fraction shouldn't be an issue because, again, as long as you have a tool around, you should be okay. But here is the part where you have to make sure you're careful. Your variables, I would do each one of those variables individually in alphabetical order. So x has 2 here, plus 1, minus 8. So 2 plus 1 minus 8. Again, there's 2 x's here, 1 x there, negative 8 there. That makes 3 minus 8, which is negative 5. So this is x to the negative 5th. Y has 7 and 3. And 7 and 3 obviously make y to the 10th. Now here's a rule you have to learn how to follow, and it's that you cannot have a negative exponent. You can have a negative number, you cannot have a negative exponent, because remember that x wants to move. So your answer is negative 16 y to the 10th over x to the positive 5th. Remember that negative exponent property that I showed you? That's where it all comes into play. And again, that's why the power properties are tough, because there's so many things in there that if you don't catch it, if you don't know what you're supposed to do, it will cause you to make a mistake and miss easy points that you know you could have caught if you were paying attention. The word that should come to mind here, because I see the floating 3, is distribute. But before I distribute that 3, I would probably try to simplify this stuff. Again, numbers by themselves, 30 over 20 reduces to be 3 over 2. And I'm going to expand this line a little bit because I'm going to do some work off on the side. In terms of my x's, it's negative 6 minus negative 2, which makes negative 6 plus 2, which is negative fourth. That means it's x to the negative fourth. And if you think about it, x to the negative fourth means it wants to be on the bottom. That's why the x to the fourth goes here. Looking at my y's, it's 15 minus negative 2, which ends up being 17. Notice this is positive, so your y to the 17th ends up here. Looking at my z's, you have negative 3 minus negative 1, which is negative 2, and again, because that's negative, it means that my z to the second is going to be on the bottom. Now here's the other thing, you can't forget about the fact that that 3 was out there, and so now you distribute it to everything, so it becomes 3 to the third. That's why you got to remember the distribute part. Y to the 51st, 2 to the third, x to the 12th, z to the 6th, which again, you can't leave a number going to a power. You can't do anything about the variables, but this turns into 27 because that's what 3 to the third is. Y to the 51st over 8, x to the 12th, z to the 6th. And again, this is where all your work comes in. We distributed. What we just did here is we distributed, we simplified a fraction, we did the quotient property, and then we did more stuff when we distributed and had to simplify it even further. So again, make sure you're practicing this, because if you don't, it's going to really catch you, and there's a whole lot of stuff in this chapter that's meant to catch you. I want to say that this is a hard chapter or a hard section for the chapter, but I think it actually gets worse as we keep going, so we want to make sure we get this down. This is simply distributive property. It's going to be negative 40 with 2 x's and 5 y's, because there's 3 here and 2 there. This is going to be positive 70 with 2 x's and 5 y's. That's kind of strange that I would do that, but I guess it works. And then 5 times 6.2, if you watch this carefully, first off, it's positive. 5 times 6 is 30. 5 times 0.2 is 1, isn't it? Because 20 cents 5 times. So I think this would be 31. I'll even check that with the calculator just to prove it. 6.2. Don't care about the sign, but the number itself is 31 again, because 5 times 6 is 30. 5 times 0.2 is 1. Put those together. This ends up with 1x because there's no other x's, and y to the 7th. And the last thing you have to be careful on is putting your like terms together. So go ahead and get over to your homework. Make sure again you ask as many questions as you need of each other, of me. Keep in mind again, you are in a spot right now where you're actually doing pretty well, but you've got to make sure you continue to ask questions and pursue this knowledge, because if you don't, you could bump into a streak that could put you in a bad spot for a long time. So again, you do have all day tomorrow to work on this, as well as the rest of the hours today. So make sure you again get as far as you can on your homework, ask as many questions as you need to, and other than that, Math XL is waiting. Good luck.